The sea had always been the first line of defense. For generations of soldiers raised on the island fortification doctrines of the empire, it was a natural barrier as much as a strategic one. Coral reefs, sharp as knives and stretching hundreds of meters from the shore, made any large landing treacherous. The shallows were mined, the beaches pre-sighted for artillery, and the tide charts memorized by commanders who believed they understood exactly how an enemy invasion would unfold. Boats would come first, slow and vulnerable as they pushed through the surf. Infantry would spill onto the beaches in waves, crawling forward under fire. Only once the beachhead was secure, days or even weeks later, would the enemy's armor roll ashore on landing craft or pontoon docks. This assumption shaped every bunker, trench and gun pit Japan built across its Pacific defenses. On islands like Saipan, Peleliu and Iwo Jima, engineers carved firing positions into volcanic rock and coral ledges with painstaking precision. Pillboxes were constructed with overlapping arcs of fire, concrete embrasures positioned to catch assault troops the moment their landing craft dropped ramps. Anti-tank ditches and steel obstacles were laid behind the beaches, not on them, because no one expected a tank to appear until the second phase of an invasion. Heavy artillery was emplaced further inland, aimed to break apart armored formations. Once they had crawled ashore, the very concept of a tank was rooted in land warfare, a lumbering beast of steel and treads, powerful on open ground but hopeless in the surf. The defenders who waited on the beaches of the Marianas in 1944 had been told that their greatest advantage was geography itself. The Pacific was vast, treacherous, and unforgiving. Amphibious warfare was difficult even for infantry, let alone for armored vehicles. Many Japanese officers had studied reports from the First World War and early Allied operations in North Africa, where tanks had to be landed by crane or roll-off pontoons, slow and exposed to fire. They envisioned days of battle before mechanized units could pose a threat. Plenty of time to bleed the enemy on the beaches. This confidence was not arrogance. It was calculation. It was the result of careful war planning and logistical reasoning, based on what had always been true. And in a war where Japan could not match America's industrial output, tank for tank or ship for ship, such defensive calculations were essential. Every yard of beach had to be contested, every delay exploited. Japanese commanders believed that if they could inflict heavy enough casualties before armor arrived, the enemy might be forced into withdrawal or reconsider its campaign altogether. The coral, the tide, and the sea itself, these were allies they could trust. Yet beneath the calm horizon, change was coming. Unknown to those crouched behind sandbagged firing slits or peering through rangefinders at the blue expanse beyond the reefs, engineers thousands of miles away had been solving the very problem the Japanese considered unsolvable. The Americans were reimagining the tank not as a land-bound instrument, but as part of a seamless amphibious assault system, one that would deliver firepower and armor to the beach in the first wave, not the last. The fundamental assumption behind Japan's coastal defenses, that the sea would slow the enemy's heavy weapons, was about to collapse. When reconnaissance units reported new types of landing craft, most dismissed them as minor innovations. Even as rumors spread of vehicles that could swim, few believed a fully armed tank could traverse open water. It sounded like fantasy, a misinterpretation of equipment tests or propaganda meant to demoralize the defenders. Yet, on the eve of the Saipan landings, some officers felt a subtle unease they could not explain. They had prepared for men and rifles, for small boats and artillery barrages. They had not prepared for what was coming. Armored shapes that would emerge from the surf itself, shedding the sea like a second skin, and bringing with them the full weight of industrial warfare. The shoreline illusion was deeply rooted, a belief not just in physical geography, but in the limits of technology and imagination. It was a belief that wars were fought in predictable ways, that tanks belonged on dry ground, and that the sea's depth and power could always be counted upon to protect a fortress island. In the Pacific of 1944, that belief would die in the surf, crushed beneath treads that no one had expected to see. The ocean that had once seemed a wall would become a highway, and the defenders who had trusted in distance and water would find themselves facing enemies far closer, far faster, and far more prepared than they had ever believed possible. The idea of a tank that could swim sounded absurd to many at first, a contradiction in terms, a fantasy that ignored the brutal realities of weight, buoyancy, and machinery. Tanks were designed for land, for grinding through mud and rubble. With steel treads and heavy armor, they were the antithesis of anything that floated. But in the Pacific War, where the next battle was always separated from the last by hundreds of miles of open water, absurd ideas became necessary ones. Each new island posed the same unforgiving problem: how to bring overwhelming firepower ashore fast enough to break the beach defenses before they tore apart the first wave of infantry. Landing craft could deliver men, but without armor, those men would face machine guns and fortified bunkers with little more than rifles and grenades. The U.S. Navy and Marine Corps needed a solution that defied the natural order, and American engineers were determined to build one. The work began long before the first Sherman ever rolled into the surf. Experiments with amphibious armor stretched back to the interwar years, when military planners studied British attempts to float light tanks on pontoons. Early trials were clumsy and often disastrous, with underpowered engines and unstable flotation devices causing tanks to capsize before they ever reached shore. But each failure taught valuable lessons about balance, displacement, and propulsion. By the time the United States entered the war, the concept of a swimming tank had evolved from a novelty into a strategic necessity. It was no longer a question of if a tank could float. It was a question of how to make one that could not only cross water, but also fight effectively the moment it landed. The breakthrough came with the Duplex Drive system, an ingenious combination of flotation, screens, and marine propulsion that transformed the familiar Sherman into something entirely new. The M4A3 chassis, already proven in combat across North Africa and Europe, was chosen as the foundation. To make it seaworthy, engineers surrounded the upper hull with a collapsible canvas skirt, supported by a frame of inflatable tubes. When raised, the skirt trapped enough air to give the 30-ton tank buoyancy. When lowered, it folded neatly against the sides, allowing the tank to fight like any other Sherman. Propulsion was provided by twin propellers mounted at the rear, driven by the main engine through a specialized gearbox. The exhaust system was sealed to prevent water ingress, and watertight hatches kept the interior dry, even as waves slapped against the hull. The system was far from elegant, but it worked. Trials in American bays and British estuaries demonstrated that the amphibious Shermans, nicknamed DD tanks for their duplex drive, could travel several miles through calm seas and surf onto a beach under their own power. Marines practiced launching them from landing ship tanks, LSTs, watching in fascination as the armored silhouettes slipped into the water and bobbed forward like ungainly boats. Once their tracks touched sand, the tanks would surge forward, shedding their canvas skirts in minutes and pivoting into firing positions with the same lethality as their land-based counterparts. This capability represented more than just a technological achievement. It was a strategic revolution. Until then, tanks had always been secondary elements of amphibious warfare, arriving hours or days after the initial assault. Now they could be part of the first wave. The psychological advantage was enormous. Instead of watching helplessly as infantry were cut down by entrenched defenders, Marines could land under the cover of 75mm shells and coaxial machine guns, Japanese pillboxes that had been designed to resist rifle fire were suddenly vulnerable to high-explosive rounds. Anti-tank teams, expecting a slow, deliberate armored advance from inland, now faced immediate threats within minutes of the landing craft dropping their ramps. The M4A3 Amphibious variant was not without its flaws. The flotation screens were fragile and could be torn by heavy seas or shrapnel. The tanks were vulnerable while in the water, unable to maneuver quickly or change course once launched. Many were lost in rough surf during early operations, but the value they brought to the beachhead was undeniable. Each successful landing demonstrated the power of combining industrial engineering with tactical necessity, a hallmark of American wartime innovation. More than any weapon or vehicle before it, the Amphibious Sherman embodied the spirit of the Pacific Campaign. It was not designed for the plains of Europe or the steppes of Russia. It was designed for coral beaches, volcanic slopes, and lagoons ringed with fire. It was a machine built for a theater where land and sea were inseparable, where the outcome of battles depended not just on strength, but on the ability to deliver that strength precisely where it was needed. By the time its treads churned onto Pacific beaches, the M4A3 was more than a tank. It was the physical expression of a new kind of warfare, one in which the boundary between ocean and battlefield had been deliberately, permanently erased. Long before the first of them churned toward a hostile beach under fire, the amphibious Shermans had to prove they could even exist. The idea looked sound on paper: flotation screens, propeller drive, sealed exhaust. But theory was one. In thing and war was another. The Pacific was not a laboratory. It was a vast, restless expanse of saltwater, unpredictable tides, and grinding surf that punished anything too heavy or too fragile. Before the tanks could be trusted with the lives of the men who would ride behind them, they had to face that reality in controlled conditions. That meant tests, dozens of them, conducted along quiet stretches of American coastline, where engineers, sailors, and Marines watched steel monsters attempt what once seemed impossible. The first trials were almost theatrical in their uncertainty. Navy sailors lined the decks of landing ship tanks, squinting down at the water below as the canvas screens were raised around the Sherman's hulls. From above, they looked like strange, oversized rafts with gun barrels poking out like the snouts of prehistoric creatures. Crews inside felt the same mix of skepticism and anticipation. Even a small leak could doom them. A burst wave could swamp the flotation screen and send 30 tons of steel to the bottom in seconds. The order would come over the radio, and one by one, the tanks slid down ramps into the water with a splash that was deeper and heavier than any ship's boat. For a long moment, they would bob uncertainly, then settle, the propellers catching water and pushing them forward into the surf. What followed was part science experiment, part rehearsal for the future. The tanks were driven across bays and coastal lagoons, their propellers churning slow but steady wakes. Marine crews learned to compensate for wind drift and current, steering the lumbering vehicles toward designated beach markers. Naval observers recorded the angle of approach, the rate of advance, and the time it took to cross specific distances. They watched how the flotation screens responded to swells and how easily they could be lowered once the tanks grounded. Each test ended the same way, with the Sherman crawling up out of the water, shedding its canvas skirt in minutes and pivoting its turret toward a target painted on the sand. The moment the tracks bit into firm ground, it was a tank again, a fully armed, fully operational piece of battlefield machinery. But testing was not only about proving the design, it was about writing doctrine from scratch. The U.S. Navy and Marine Corps had no prior playbook for launching tanks directly from ship to shore. Entire procedures had to be invented. Crews drilled launching sequences repeatedly, learning the timing of lowering ramps and synchronizing propulsion startup with the surge of the sea. They practiced emergency responses, what to do if a flotation screen tore, if an engine stalled mid-channel, if a propeller jammed in sand. Training also revealed subtle weaknesses that engineers hurried to fix. New materials for sealing exhaust systems, reinforced points on the flotation frame, modified gear ratios to improve water speed. These rehearsals became more elaborate over time. Entire platoons of Shermans were launched simultaneously, advancing in formation like a slow-moving steel flotilla. Engineers installed observation cameras to capture how waves struck the screens. Naval architects calculated ideal launch distances from shore and optimized LST deck layouts to speed deployment. The tests extended beyond calm harbors into rougher waters, where the tanks faced chop and whitecaps meant to simulate Pacific conditions. Losses did occur. A handful of vehicles sank or flooded during early trials, but each mishap was catalogued, dissected, and folded into improved designs and revised procedures. By the time the amphibious Shermans were declared combat-ready, they were more than just machines that could float. They were part of a finely tuned system, a choreography of ship handling, timing, and coordination that would unfold with precision during actual assaults. Reports from those pre-war tests read almost like prophecies. They spoke of how quickly the vehicles could deploy from LST ramps, how effectively they could stabilize in open water, and how seamlessly they transitioned from sea to shore. Few outside of the Allied command circles ever read those documents, and almost none among the Japanese staff officers believed them possible. In Tokyo and Truk, the idea of a fully armed tank swimming ashore still sounded like rumor or exaggeration. Yet on isolated American coastlines, under the watchful eyes of engineers and Marines, the impossible was being rehearsed until it became routine. And each rehearsal brought the day closer when the illusion of tankless beaches would shatter. Forever! Japanese planners preparing for the inevitable American advance across the Pacific did not see their island garrisons as disposable outposts. They saw them as fortresses, static, heavily reinforced, and meticulously designed to absorb the shock of invasion and bleed the enemy until his will faltered. The strategy was rooted in geography, doctrine, and necessity. Japan's industrial base could not replace lost ships and tanks at the same pace as the United States. Its air and naval superiority had evaporated after Midway and the relentless submarine blockade that followed. What remained was land, the volcanic ridges, coral plateaus, and jungle-choked interiors of its island holdings, and the belief that these could be turned into killing grounds where American numerical superiority would count for less. This defensive mindset shaped every decision about where to place weapons and how to build defenses. Artillery batteries were positioned inland, often hidden in caves or recessed into hillsides to avoid naval bombardment and engage landing forces once they were trapped on the beach. Anti-tank guns, precious and few, were placed well behind. The shoreline aimed not at the surf, but at the roads and choke points where armored columns were expected to appear days after the initial landings. Engineers spent months constructing concrete pillboxes with fields of fire tailored for infantry engagements. Interlocking machine gun nests were designed to mow down assault troops the moment they stepped off their landing craft. Even the beaches themselves were engineered to slow and channel the enemy. Barbed wire, wooden stakes, and landmines were arranged in deliberate patterns to funnel attackers into kill zones where mortars and rifles could do maximum damage. Underlying all of this was a fundamental assumption. Tanks were not part of the opening act. They were too heavy, too clumsy, too dependent on ports or piers to arrive with the first wave. Every major amphibious landing before the Pacific War had confirmed this. At Gallipoli, Dunkirk, and even in North Africa, tanks followed long after. Infantry had established a foothold. Japanese staff officers considered it a law of modern war. Infantry would come first, followed by engineers and logistics units, and finally, after beachheads were secure and temporary docks constructed, armor would roll ashore. Their defenses reflected this sequence. The Pacific Islands themselves reinforced this belief. Coral reefs, extending hundreds of meters from shore, would stop any heavy craft long before it could reach land. Shallow lagoons, tidal flats, and soft sand were expected to trap anything with tracks. And even if the Americans somehow managed to bring tanks ashore quickly, those vehicles would be funneled into pre-sighted kill zones, where they could be immobilized and destroyed by anti-tank fire waiting deeper inland. In this conception, the beach itself was a moat, a deadly no-man's land meant to delay and disrupt until heavier Japanese counterattacks could be launched. Training materials and intelligence briefings distributed to garrisons on islands, like Saipan, Tinian, and Iwo Jima, repeated the same assumptions. The enemy's heavy vehicles will require ports or piers. One manual from 1943 advised, "Our artillery shall reserve its fire for this phase." Maps of defensive plans show anti-tank units positioned near crossroads and airfield perimeters, not on the beach itself. Infantry platoons were instructed to focus their fire on landing craft and lightly armed troops, leaving heavier weapons idle until the moment came to confront tanks days later. It was a logical plan, until it wasn't. The very assumptions that had guided fortress construction and defensive doctrine were already being undermined thousands of miles away, where American engineers were transforming the Sherman into a machine that could ignore the moat entirely. By the time those tanks churned through surf and rolled up beaches in the opening minutes of an assault, Japan's carefully layered defenses would be oriented toward threats that no longer followed the expected sequence. Artillery would be out of position. Anti-tank crews would be waiting too far inland. Machine gun nests designed to pin infantry would suddenly find themselves facing high-explosive shells from tanks that were never supposed to be there. This strategic blind spot was not a failure of imagination so much as a consequence of fighting a 20th century war with 19th century assumptions. Japanese commanders believed in the sanctity of the natural barrier, in the predictable pace of amphibious operations, in the immutable laws of how war was fought. They were not alone. Many Allied officers shared those beliefs before the first. Amphibious Shermans proved otherwise. But once that proof appeared, crawling out of the sea under fire, it rendered entire defensive doctrines obsolete. The fortresses Japan had built were formidable, but they had been designed to fight yesterday's war. And on the beaches of the Central Pacific, that mistake would cost them dearly. The morning of June 15, 1944, began with the heavy stillness that often precedes catastrophe. The horizon beyond Saipan's coral reef was already thick with shapes, the silhouettes of transports and landing ships stretching as far as the eye could see. Japanese soldiers had been watching the build-up for hours, squinting through rangefinders from their cliffside observation posts. They knew the invasion was inevitable. It was the culmination of weeks of bombardment and aerial reconnaissance. But what they expected to follow was familiar. Waves of landing craft carrying infantry, supported by naval guns and aircraft. Tanks would come later, days perhaps, when the beaches had been secured and pontoons assembled. That was how invasions had always unfolded. Yet as the first light of dawn swept over the Pacific, something about the formation advancing toward them seemed different. The initial waves looked ordinary enough, the low, stubby silhouettes of Higgins boats cutting through the surf, their wakes foaming white against the blue. But behind them further out, a second line of dark, boxy shapes followed a slower, steadier course. At first, observers assumed they were barges or specialized landing vehicles. Some officers dismissed them entirely, focusing their binoculars on the troop carriers drawing closer. It was only when the second line neared the reef that the illusion began to fracture. Through the morning haze, details became visible, angular profiles, protruding barrels, the unmistakable geometry of armored turrets. The shapes were not barges at all, they were tanks, and they were moving under their own power. For a few minutes, confusion reigned in the Japanese command posts. Reports poured in from coastal lookouts describing unidentified craft advancing directly toward the beaches. One junior officer suggested they were armored boats. Another speculated they might be decoys meant to draw fire. But then, as the waves shallowed and the shapes lifted slightly with the swell, canvas screens around their hulls began to fold down like curtains. What emerged from beneath were not boats or decoys, but M4A3 Shermans, American tanks rolling across the water, as if the sea itself had become a highway. The disbelief among the defenders was palpable. Men who had spent years fortifying their island against conventional landings now stared at a sight no doctrine had prepared them for. Armored vehicles approaching the shore before the first riflemen had even stepped onto the sand. The guns that lined Saipan's beaches had been calibrated for infantry assaults. Machine guns opened fire instinctively, their bullets sparking uselessly off wet armor. Mortar crews scrambled to adjust their sights. But the tanks kept coming, their propellers churning steadily as they climbed over the shallow reef and slid into the surf zone. Then, with a grinding hiss, the first Sherman's tracks bit into the sand. Within moments, its turret rotated toward a bunker and loosed a high explosive round that detonated with a roar among the defensive positions. Pillboxes that had been designed to resist rifle fire disintegrated under the blast. Across the length of the beachhead, similar scenes unfolded. Amphibious Shermans emerged from the waves one after another, shedding their flotation skirts and pushing inland. Behind them, Marines advanced under the cover of tank fire, moving in coordinated formations that exploited the sudden gap in Japanese defenses. The plan that had been designed to funnel lightly armed infantry into kill zones was collapsing. Anti-tank guns, positioned too far back to respond in time, were overrun or destroyed before they could be brought to bear. Bunkers that were supposed to hold out for hours were neutralized in minutes. For the Japanese soldiers on Saipan, the psychological impact was as devastating as the physical destruction. Diaries and post-war interrogations would later record the disbelief and panic that swept through frontline units. Some described the tanks as steel fish or monsters born from the sea. Others wrote of their confusion at seeing armor appear in places they had thought impassable. It was not simply that the Americans had brought tanks ashore. It was that they had done so at the very beginning of the battle, overturning every expectation the defenders had held. By mid-morning, the beachhead was firmly in American hands, and the amphibious Shermans were advancing inland alongside infantry and conventional armor that had arrived later. But the battle's decisive moment had already passed hours earlier, when those first dark shapes appeared on the horizon and revealed themselves as something no one in the Imperial General Staff had believed possible. The fortress strategy that had defined Japan's island defenses had been built on the assumption that the sea itself would delay heavy armor. On the beaches of Saipan, that assumption died under the treads of tanks that refused to wait. The war in the Pacific would never look the same again. The first bursts of fire cracked through the morning air as the amphibious Shermans closed the last stretch of water between the reef and the beach. Japanese machine gunners, still reeling from the shock of what they were seeing, did what training had taught them. They squeezed their triggers and poured streams of bullets into the surf. But the result was unlike anything they had experienced before. Tracer rounds hissed into the water and died with brief, futile splashes. The few that struck their targets pinged harmlessly off the angled armor of the advancing tanks, leaving only scars in the paint. The gunners adjusted their aim, shifted positions, tried to concentrate their fire, but nothing slowed the strange, lumbering shapes that churned forward with unstoppable purpose. As the tanks entered shallower water, they became even more surreal to watch. The long canvas skirts that had kept them afloat began to sag and collapse, folding down against the sides like deflated sails. What had moments earlier appeared to be ungainly boats now revealed themselves fully as tanks, complete with thick armor, heavy turrets, and the familiar snub-nosed 75mm gun that had been terrorizing Axis positions in Europe for 2 years. Spray fanned out from the treads as they gripped the seabed, the vehicles lurching forward with a steady mechanical growl. Within minutes, they were crawling up the beach, seawater cascading off their hulls as if they had risen straight from the depths. The Japanese positions, built to repel infantry, were suddenly obsolete. Concrete pillboxes with narrow slits designed to rake advancing riflemen were now vulnerable to tank fire. The first Sherman to ground itself rotated its turret toward a machine gun nest, dug into the slope, and fired a high-explosive shell. The impact was devastating. The emplacement, which might have held off hundreds of infantrymen for hours, vanished in a cloud of pulverized sand and shattered concrete. Others followed suit, firing round after round into strong points that had been constructed with no expectation of facing direct tank assault so soon. The defenders tried to adapt. Mortar teams shifted their tubes to fire on the armored intruders, but the shells detonated harmlessly against sloped steel or burst too far behind them to cause damage. Anti-tank squads, stationed deeper inland as doctrine dictated, scrambled to reposition, but the distance was too great and the confusion too intense. In the time it took them to wheel their guns into place, the Shermans had already broken through the first defensive lines and were supporting Marine infantry pushing inland. For the Japanese soldiers on the ground, the experience was as psychologically destabilizing as it was tactically disastrous. They had been taught to view tanks as ponderous, methodical weapons, terrifying in their power but predictable in their limitations. Now those limitations were gone. The tanks were not waiting for ports or causeways. They were not bottlenecked by logistics or terrain. They were there from the very beginning, rolling over obstacles, crushing barbed wire, and blasting apart emplacements that had been carefully prepared for a different kind of enemy. It felt as though the rules of warfare had changed in an instant. Accounts from survivors later described the sense of helplessness that swept through the Japanese positions. Men who had spent months fortifying beaches with mines and stakes watched as the Shermans simply drove over them. Some tried to rush forward with satchel charges or magnetic mines, but the tanks, working in tandem with advancing infantry, cut them down before they could close the distance. Others withdrew deeper into the island, hoping to regroup, only to be pursued by armor far earlier than anyone had believed possible. What unfolded on Saipan was more than just a battlefield engagement. It was the collapse of an entire defensive philosophy. The Japanese fortress strategy had been built on the assumption that the sea itself would delay mechanized firepower. The Shermans shattered that assumption not through overwhelming numbers or brute force, but through motion. Through the simple, stunning fact that they could move where tanks were never supposed to go. Their relentless advance from water to sand to soil left defenders with no time to think, no time to adjust, and no chance to stop the inevitable. By the time the smoke began to clear over the beaches, the amphibious Shermans were no longer curiosities or engineering experiments. They were the spearhead of a new form of assault, one that rendered pre-war doctrines irrelevant and left those who clung to them watching in disbelief as the tide of war literally rolled past their defenses. The arrival of the amphibious Shermans did more than simply add firepower to the assault. It rewrote the geometry of the battlefield itself. The defensive network the Japanese had so carefully constructed across Saipan and other Pacific islands was designed around a predictable pattern of movement. Infantry would land first, probing for weaknesses and absorbing casualties while artillery and machine guns cut them down in pre-sighted kill zones. Then, hours or days later, armor would follow, lumbering forward along routes already mapped and studied by defenders. The Japanese plan relied on this sequencing. Their fields of fire were plotted to intersect along choke points where tanks would be forced to advance. Their trenches were dug to funnel infantry into the teeth of overlapping machine gun arcs. Their artillery was held back to smash the armored spearhead once it entered range. Every meter of sand and soil had been measured, every angle calculated. But all of it assumed time. And time was precisely what the Shermans stole away. From the first moments of the invasion, the tanks were there. They did not lumber forward hours after the battle had begun. They emerged from the surf with the first wave. Their guns barked even as water dripped from their hulls, throwing high-explosive rounds into positions that had been built to resist. Rifles and grenades, not 75mm shells. Japanese machine gunners, who had expected a slow, deliberate armored advance from inland, suddenly found themselves facing tanks on their flanks before they could even reposition. Entrenchments that had been intended as defensive funnels became death traps as the Shermans rolled over them, crushing sandbag walls and flattening parapets beneath their treads. One of the most devastating consequences of this unexpected presence was the collapse of interlocking fields of fire. Japanese doctrine emphasized carefully planned overlapping kill zones, where infantry and light vehicles would be caught in converging lines of machine gun and mortar fire. But these firing lanes were calibrated for human targets, not heavily armored vehicles. As the Shermans pushed inland, they created breaches that split the defensive network apart. Bunkers designed to provide mutual support were isolated and destroyed one by one. Pillboxes that were supposed to enfilade infantry columns were neutralized before they could deliver sustained fire. The geometry of the battlefield, once a carefully plotted trap, became a disjointed maze of shattered strongpoints and disrupted communication lines. The defenders scrambled to adapt, but they were always a step behind. Anti-tank guns positioned well behind the beach, meant to engage armor advancing along predictable inland routes, had to be hastily repositioned. In many cases, they never made it into the fight at all. By the time they were unlimbered and set up, the Shermans had already bypassed their intended fields of fire or destroyed their emplacements with indirect shelling. Infantry units, trained to lure tanks into prepared kill zones, found themselves forced into desperate improvised assaults with explosives and satchel charges, attacks that were often suicidal against tanks operating in close coordination with supporting infantry. The psychological effect of this inversion was immense. Soldiers who had spent months preparing for a specific type of battle suddenly found themselves in an entirely different war. Instead of controlling the tempo of the engagement, bleeding the enemy, slowing their advance and dictating the terms of battle, they were reacting, improvising, and retreating. The confidence that came from meticulous planning evaporated in the face of tanks appearing in places they should never have been. Defensive positions that had been expected to hold for days collapsed in hours, and entire companies were forced to abandon carefully built fortifications that had been rendered useless. It was not just firepower that broke the Japanese lines. It was movement. The Shermans moved faster than doctrine accounted for, struck from directions that were never plotted on defensive maps, and supported assaults with a weight of force that frontline units had not believed possible so soon after an invasion began. Every aspect of the fortress strategy depended on shaping the battlefield, channeling the enemy into predictable paths and punishing them there. But the amphibious tanks refused to follow those paths. They made their own, across trenches, over wire, and through the heart of the positions that were supposed to stop them. By the end of the first day on Saipan, The evidence was unmistakable. Japanese defenses that had been built over months were gone in a matter of hours. Lines that had once seemed impregnable had been torn apart not by overwhelming numbers, but by the sudden presence of machines that defied the very logic upon which those defenses had been constructed. The amphibious Shermans had done more than land. They had shattered the geometry of battle itself, and with it, the illusion that careful planning alone could stop the relentless tide of American industrial war. By the spring of 1945, the lessons learned from Saipan, Tinian, and Peleliu had been absorbed and refined into doctrine. What had once been a bold experiment was now a standard feature of the American amphibious arsenal. The M4A3 Sherman amphibious variants were no longer curiosities deployed in limited numbers. They were essential components of the first wave. Crews trained relentlessly for launch operations, rehearsing the sequence of rolling from the cavernous decks of landing ship tanks straight into open water. Naval and marine commanders coordinated their movements with precision, timing their deployment to coincide with the peak of the tide and the rhythm of naval bombardments. The result was a choreography of mechanized assault that unfolded with deadly efficiency, and nowhere was this more evident than on the blood-soaked beaches of Okinawa. The invasion, codenamed Operation Iceberg, was the largest amphibious assault of the Pacific War. American planners expected ferocious resistance. Okinawa was not just another island outpost. It was the last barrier before the Japanese home islands themselves. Its capture would provide a base for the planned invasion of Kyushu and Honshu, and Tokyo knew it. The Imperial Japanese Army had fortified every ridge and ravine with layers of artillery, mines, and concealed bunkers. On paper, the defense was formidable, but by 1945 the defenders had already seen what American ingenuity could achieve. They had witnessed tanks emerging from surf where no tank should exist. They knew the sea could no longer be trusted to keep the enemy's armor at bay. Still, nothing could fully prepare them for the scale of what they saw on April 1st, 1945. At dawn, as the sky shifted from black to the pale grey of early morning, the horizon erupted with movement. Hundreds of ships ringed the island, launching waves of landing craft toward the beaches. From the cliffs and caves above the shoreline, Japanese officers trained their binoculars on the invasion armada and saw a sight that seemed to defy logic. From the open mouths of the LSTs, platoons of Shermans rolled straight into the sea, their canvas skirts rising like collars around their hulls as they bobbed in the waves. They moved with slow, deliberate determination, their propellers pushing them forward in unison as they advanced toward shore in tight formation. One officer watching from the hills later described the spectacle in his diary as unreal, as if the sea itself produced tanks. For the American crews inside those steel beasts, the approach was tense but methodical. They felt the slight sway as waves slapped against their hulls, heard the churn of propellers below their feet, and watched through periscopes as the beaches grew larger with every passing minute. Naval gunfire thundered overhead, smashing Japanese defensive positions and showering the shoreline with debris. As they neared the shallows, the familiar ritual began. Flotation screens were dropped, water drained from their hulls, and the tanks surged forward, their tracks clawing into the sand with a hiss and rumble that echoed across the coastline. Once ashore, the Shermans wasted no time. Their guns roared almost immediately, targeting machine gun nests and mortar pits still recovering from the pre-invasion bombardment. The effect was devastating. Bunkers that had survived naval shelling crumbled under direct tank fire. Defensive. Trenches were flattened beneath treads, their occupants scattered or buried. The Japanese defenders had expected armor, but not this quickly, and not in such overwhelming numbers. The very concept of delaying tanks until after infantry had landed was now obsolete. The Shermans were no longer following behind. They were leading the assault. The psychological weight of that reality bore heavily on the defenders. Many who had once believed the shoreline to be a final line of defense now saw it as nothing more than a killing ground. The tanks moved with grim inevitability, their presence transforming the nature of the battle before it had truly begun. Infantry followed close behind them, shielded by their armor and supported by their fire. Each advance was measured and coordinated, with tanks and marines moving as a single lethal organism. Okinawa would become one of the bloodiest battles of the war, a brutal campaign fought over ridges, caves and villages in a grinding struggle that lasted nearly 3 months. But the pattern of the fight was set in those first few hours when the Shermans crawled out of the sea and made the beach their own. What had once seemed impossible was now routine, a mechanical tide that rolled forward with as much inevitability as the waves themselves. By the time the smoke cleared from the beaches and the first foothold was secured, the Japanese defenders knew that the era of fortress warfare was over. The sea, which they had once counted as their ally, now belonged to the enemy. And from its depths rose steel giants that would drive relentlessly toward the heart of their homeland. The first time a tank emerged from the surf, it did not feel real to those watching. Men who had spent years drilling in the doctrines of imperial defense, who had memorized tide tables and studied beach gradients, suddenly found themselves staring at something that should not have existed. In the confusion and smoke of battle, many soldiers thought they were seeing landing craft or armored boats, but then the shapes moved differently, slower, heavier, purposeful in a way no boat ever was. They did not bob helplessly with the tide. They carved through it, propellers churning the water beneath steel hulls that did not belong in the sea. When the canvas screens folded down and turrets swung into place, a chill ran through the defenders. The impossible had become real. Accounts from the men who survived those moments speak of a kind of stunned paralysis. Diaries recovered after the battles of Saipan, Tinian, and later Okinawa are filled with words like unthinkable, unnatural, and iron beasts swimming like fish. Many of the writers confessed they had hesitated to fire at first, convinced that what they were seeing must be some sort of trick. One infantryman on Saipan wrote that his entire squad stood motionless for nearly a minute as the first Sherman crawled out of the surf, its tracks dripping seawater, its turret already turning toward their position. "We had trained for tanks," he wrote, "but not for tanks that come from the ocean." This disorientation was more than just a momentary lapse. It was the collapse of deeply ingrained assumptions about warfare. Japanese soldiers had been taught to believe that industrial power alone could not win wars. Courage, discipline, and spiritual strength were held as the deciding factors. Their training emphasized the human element, the will to fight, the readiness to sacrifice, the capacity to endure. The sight of a tank swimming ashore, a machine built not only to defy physical limitations, but also to arrive precisely when and where doctrine said it could not, shook that belief to its core. If American engineers could make steel float, what else could they do? The emotional toll of that realization spread quickly through the ranks. Reports from captured soldiers and post-war interrogations reveal that many defenders felt an overwhelming sense of helplessness as the amphibious tanks advanced. Anti-tank crews tasked with holding their fire until armor reached inland choke points now found themselves scrambling to reposition their guns. Sappers trained to attack vehicles with explosive charges were forced to rush headlong into fire. Before they could even get close, even seasoned veterans who had faced tanks in China or the Philippines admitted that this new kind of warfare felt alien, as though the Americans were fighting a completely different war, one shaped not by human endurance but by limitless mechanical ingenuity. Fear, too, was impossible to ignore. In some accounts, soldiers describe watching Shermans crawl ashore under fire, shells exploding around them, machine guns spitting traces, and yet nothing seemed to stop their advance. One junior officer on Okinawa likened them to monsters, of iron, slow and deliberate, impervious to everything they threw at them. They moved as if they knew we could do nothing, he wrote, and in truth, we could not. This feeling of inevitability, that no matter how fiercely they resisted, the enemy would simply build something bigger, stronger, and more advanced, was deeply demoralizing. It also sowed doubt. Among the younger soldiers especially, the myth of Japan's superiority, the idea that purity of spirit could overcome material inferiority, began to crumble. Some asked quietly whether their nation's focus on willpower had blinded it to the realities of modern war. Others wondered if victory had ever been possible against a nation capable of turning an ordinary tank into a machine that could conquer both sea and land. Even officers who remained outwardly defiant admitted after the war that the psychological blow was severe. One major captured on Saipan told his interrogators that the appearance of amphibious tanks did more to break morale than weeks of bombardment. It was not just a weapon, he said. It was a message that America's imagination was stronger than ours. By the end of the war, that message had been received across every battlefield of the Pacific. The tanks that crawled out of the sea were more than steel and firepower. They were proof that the United States could not only outbuild Japan, but outthink it, that the boundaries the Japanese believed would hold were nothing more than illusions to be swept aside. And as those illusions crumbled, so too did the confidence that had once sustained Japan's armies. The defenders who had called them iron beasts were right. They were more than machines. They were symbols of a new kind of war, one where industrial ingenuity was as decisive as courage, and where the impossible was no longer beyond reach. The first appearance of amphibious Shermans had caught Japanese forces completely off guard, but shock quickly gave way to determination. Across the Pacific, garrison commanders and field officers began searching for ways to counter the new threat, adapting tactics and reconfiguring defenses even as the fighting raged. What followed was a grim demonstration of ingenuity born from desperation, a contest between the creativity of the defenders and the resilience of the machines that had rewritten the rules of amphibious warfare. The most immediate response was the deployment of beach mines. Japanese engineers had long relied on minefields as part of their coastal defenses, but now they were repositioned closer to the waterline, buried in sandbars and coral shelves in an attempt to strike the tanks before they could reach dry land. It was a simple idea: force the Shermans to pay for their newfound mobility with heavy casualties, yet results were uneven. Many tanks survived detonations that would have destroyed lighter vehicles, their thick armor and reinforced undercarriages, absorbing the blasts. Others cleared safe paths by triggering mines deliberately, sacrificing a few vehicles so that the rest could advance. Mines slowed the assaults, but they could not stop them. Artillery presented another potential solution. Batteries were repositioned and carefully sighted to target the surf zone, where the Shermans floated in their most vulnerable state. The theory was sound: catch the tanks before they grounded, when their flotation screens were still deployed, and their mobility was limited. But in practice, this tactic rarely achieved decisive results. Naval gunfire and carrier-based aircraft relentlessly hunted down Japanese artillery positions, often silencing them before they could inflict significant damage. Those guns that survived had difficulty tracking the slow-moving but unpredictable targets. Shells that fell short were absorbed by the sea. Those that overshot exploded harmlessly inland. Even when hits were scored, the Sherman's sealed hulls and compartmentalized design often kept them operational. Some of the most dramatic and tragic attempts to stop the tanks came from infantry units assigned to close assault roles. Special demolition teams were formed, their mission simple but suicidal. Approach the advancing Shermans on foot and destroy them with satchel charges, magnetic mines, or explosive-laden poles. These units were often composed of volunteers, many of them young men steeped in the ethos of self-sacrifice. They waited in concealed positions along likely approach routes, rushing forward under fire when the tanks drew near. Few survived long enough to complete their missions. Coordinated infantry and tank tactics meant that Marines were always close behind the Shermans, cutting down attackers before they could close the distance. Even those who reached the vehicles found that the machine's armor was thicker and more resistant than expected, their explosives sometimes failing to penetrate. The Japanese also experimented with deeper defensive changes. Some commanders attempted to shift their anti-tank guns closer to the beaches, though this often exposed the weapons to naval bombardment and pre-landing strikes. Others dug elaborate trap pits and concealed obstacles inland, hoping to channel the Shermans into killing zones once they moved off the sand. But the tanks, working in coordination with engineers and reconnaissance teams, often avoided or neutralized these traps before they could be effective. The Americans adapted just as quickly as their enemy, deploying mine-clearing equipment, bulldozers, and infantry equipped with bazookas and flamethrowers to deal with the countermeasures. Despite these efforts, the fundamental problem for the Japanese never changed. The Shermans were arriving too soon and too strong. Their very presence in the opening phase of the invasion disrupted every layer of the defensive plan. Instead of facing waves of vulnerable infantry, Japanese troops found themselves immediately under fire from tank cannons and coaxial machine guns. Bunkers that might have withstood hours of assault crumbled in minutes under concentrated fire. Communication lines, vital for coordinating counterattacks, were severed before reserves could be brought forward. Even when individual tanks were disabled or destroyed, they had usually already achieved their objectives, clearing landing zones, breaking fortified positions, and supporting the infantry push inland. The psychological effect of this futility was profound. For many Japanese soldiers, each failed countermeasure was another reminder that their enemy could not be stopped by courage alone. They watched as tanks shrugged off direct hits, rolled over carefully laid traps, and kept firing even as flames licked at their hulls. "We had no answer," one survivor from the Okinawa campaign wrote. "We fought with everything we had, and still they came forward. It was as if the sea itself gave birth to them again and again." By the final year of the war, the Amphibious Sherman had become a symbol of inevitability, a weapon that rendered traditional defenses obsolete and forced Japan to confront the limitations of its strategy. Every adaptation, every desperate measure, only underscored the same harsh truth. The Americans were not just outproducing them, they were outthinking them. And against that combination of industrial strength and tactical flexibility, even the most determined resistance could only delay, never defeat, the tide rolling in from the sea. Behind the spectacle of tanks crawling out of the sea and the shock they inflicted on Japan's defenders was a hidden war. One fought not with guns and shells, but with blueprints, cranes, factories, and timetables. The Amphibious Sherman was not a miracle of sudden invention. It was the culmination of thousands of decisions made far from the battlefield, in shipyards, steel mills, assembly plants, and logistical headquarters. Its existence was proof that the United States had mastered something Japan never truly achieved during the war: the seamless integration of engineering, production, and operations into a single, coordinated system capable of projecting power. Across the globe, the process began in the design rooms and modification shops of American industry. The standard M4A3 Sherman was already one of the most widely produced tanks of the war, but turning it into a machine that could swim required specialized modifications. shipyards and manufacturing plants across the country were tasked with altering hull structures, sealing exhaust systems, and installing the Duplex Drive mechanism. Canvas flotation screens had to be produced to precise specifications, lightweight enough to deploy quickly, but durable enough to withstand rough surf. Propeller systems, gearboxes, and watertight hatches were built by companies that had never before worked on armored vehicles. It was an industrial mobilization on a massive scale, and it depended on the kind of standardized production and modular assembly that had become America's hallmark by 1943. At the same time, naval engineers and logistics officers were solving the problem of how to deliver these unusual machines into battle. Landing ship tanks, LSTs, were modified with reinforced ramps and launch platforms designed to deploy armored vehicles directly into the water. Testing showed that the angle of a ramp or the timing of a release could determine whether a tank floated or sank, so those details were refined relentlessly. Crews drilled until the process became second nature. Tanks rolled off the deck, floated free, and immediately formed up into assault formations without chaos or delay. Every element, from the moment a tank left the factory floor to the second its tracks hit sand, was choreographed to fit within the larger machinery of amphibious warfare. Supplying these tanks and keeping them operational also required an enormous logistical effort. Specialized spare parts, flotation screen replacements, and waterproofing materials had to be stockpiled and shipped across thousands of miles of ocean. Maintenance crews traveled with the fleets, trained to repair unique components that didn't exist on standard Shermans. Even fuel and ammunition supply lines were adjusted to account for the tank's dual environment. Propeller components needed lubrication suited for saltwater exposure, and waterproofed hulls had to be checked and resealed after every landing. Nothing was left to chance. The coordination extended beyond hardware. Operational planners worked hand in hand with engineers and logisticians to integrate the amphibious Shermans into broader invasion strategies. Launch timings were synchronized with naval bombardments to ensure that enemy defenses were suppressed. Before the tanks hit the surf, meteorologists provided detailed tide and wave forecasts, allowing commanders to choose the ideal conditions for launching their amphibious armor. Communications networks ensured that tank crews, infantry units, and naval support could coordinate their movements in real time, minimizing confusion during the chaotic first minutes of an assault. This fusion of engineering, industry, and logistics represented a level of sophistication that Japan simply could not replicate. Its industrial base was far smaller, its shipyards fewer, its supply lines stretched to breaking. Japanese engineers were capable and inventive, but they lacked the vast industrial ecosystem needed to turn concept into mass-produced reality. Where American factories could turn out hundreds of modified Shermans a month, Japan struggled to produce enough tanks of any type to replace battlefield losses. Where U.S. naval logistics could deliver specialized components across entire oceans on schedule, Japanese convoys were increasingly harassed and sunk before they reached their destinations. The result was a kind of military magic that seemed effortless to those who witnessed it, even though it was anything but. From the perspective of a Japanese soldier watching a tank crawl ashore, it was as if the sea itself had delivered it. But beneath that illusion was an intricate web of design, production, transportation, and planning, a network so vast and precise that it turned one of warfare's most audacious ideas into routine reality. The amphibious Sherman was more than a weapon. It was the physical embodiment of America's industrial power and organizational depth, a machine made possible only by the relentless coordination of countless hands and minds. And it was this unseen force, as much as the tanks themselves, that crushed Japan's fortress islands and reshaped the course of the Pacific War. When Japanese officers and engineers were interrogated after the war, many of them returned again and again to the same unsettling conclusion. The amphibious Shermans were more than just clever engineering. They were evidence of something far larger, an entire system capable of transforming ideas into realities at a scale Japan could not comprehend. The tanks were impressive, yes, but the true revelation was how effortlessly America had taken a concept that seemed impossible, mass-produced it, shipped it across thousands of miles of ocean, and deployed it precisely where it was needed. The lesson was not just in what the Shermans did, but in what their very existence revealed about power in the industrial age. For Japan, warfare was still, in many ways, a contest of will and courage. Its military leaders believed that discipline and fighting spirit could overcome material disadvantages. Factories in Japan worked hard, but they did so within limits, constrained by raw materials, manpower, and shipping capacity. Prototypes were built, but few reached mass production. Weapons were designed for specific battles, often handmade or modified in the field, with little consideration for how they might be supplied or replaced at scale. The idea that a nation could solve a complex engineering challenge like Amphibious armor and then build thousands of identical vehicles and deliver them halfway around the world seemed almost impossible within that framework. The United States approached the problem differently. To American planners, the development of the amphibious Sherman was not an isolated project. It was one piece in a vast logistical and industrial machine that had been mobilized for total war. Engineers and designers collaborated directly with factory managers and naval planners, ensuring that the design of the tank could be produced on assembly lines already optimized for speed and volume. The same steel mills that built merchant ships also forged armor plating. The same logistical networks that delivered aircraft engines across the Pacific also carried propellers and flotation screens. At every level, the system was integrated. Concept, production, transportation, and deployment existed not as separate challenges, but as stages of a single process. This ability to convert ideas into operational reality was one of the defining characteristics of American power in World War II. The amphibious Shermans were not the only example. The Liberty ships that carried them to the Pacific were built in weeks, sometimes days. The LSTs that launched them, from sea to shore, were designed, constructed, and deployed in numbers that dwarfed anything Japan could match. The factories that produced their engines did so alongside engines for aircraft and naval destroyers, often on the same assembly lines. This flexibility and scale allowed the United States to pursue solutions to problems without fear of overstretch. Even failures could be absorbed, lessons learned, and new iterations produced without crippling the war effort. For captured Japanese officers, this realization was sobering. They had underestimated the extent to which America's economy and industry were themselves weapons. The tanks they saw emerging from the sea were not just the products of clever minds. They were the products of an entire society organized around the goal of solving problems through technology and production. We believed that such machines could not exist in meaningful numbers, one senior officer admitted after the war, but they did not build one or two, they built hundreds. They did not deploy them as curiosities, they deployed them as part of a system. That system did more than overwhelm Japan militarily. It challenged the very foundations of its strategic thinking. It demonstrated that industrial capacity could shape the battlefield as decisively as soldiers or ships. It showed that wars, in the modern age, would be won not only by bravery and tactics, but by the ability to turn theoretical solutions into operational capabilities at scale. And it taught a painful lesson, that even the most deeply entrenched defenses, the most carefully prepared strategies, could be rendered irrelevant by an enemy who could imagine a different way of fighting and then summon the resources to make it real. In the end, the amphibious Shermans were not just a triumph of engineering. They were proof that in the industrial age, power lay in the capacity to imagine the improbable. and then to build it, ship it, and unleash it on the other side of the world. For Japan, that understanding came too late. But for the nations that would rebuild in the war's aftermath, it became a guiding principle. Strength was no longer defined only by the courage of soldiers, but by the creativity of engineers, the reach of supply lines, and the relentless machinery of an economy mobilized for war. The story of the Amphibious Sherman did not end when its tracks clawed onto sand or when its turret thundered against coastal bunkers. Its influence extended far beyond those beaches and into the very heart of military thinking. What began as a desperate attempt to solve a specific tactical problem, how to bring armor into battle at the earliest possible moment, evolved into a profound transformation of how wars would be fought in the modern era. The sight of tanks rolling ashore with the first wave had proven more than just the power of American engineering. It had demonstrated that the fundamental assumptions about amphibious warfare, assumptions that had guided planning for decades, were no longer valid. Before the Sherman's debut, amphibious assaults were largely predictable affairs. Infantry went first, lightly equipped and often suffering catastrophic losses while establishing a beachhead. Engineers followed to clear obstacles and lay temporary infrastructure. Only after the shoreline was secured would armor and heavy support arrive. To exploit the gains, this sequence had been accepted as a logistical necessity, the natural order of amphibious operations. But the Amphibious Sherman shattered that order. It showed that the boundaries between sea and land, between preliminary assault and follow-on force, could be erased. Heavy armor no longer had to wait. It could lead. The implications were enormous. Military planners around the world began rethinking the structure of amphibious operations. The United States Marine Corps, which had once treated armor as a supporting element, started integrating tank units directly into first-wave assault formations. Training manuals were rewritten to reflect the new reality. Instead of planning for tanks to arrive after the beachhead was secure, commanders began designing operations around their immediate presence. Naval architects reimagined landing craft and assault ships with tank deployment in mind, ensuring that future generations of armored vehicles could launch directly from sea to shore. The lessons learned from the Sherman's success also reached beyond America's borders. In post-war Japan, where the once proud Imperial Army had been dismantled and restructured, military thinkers studied the Pacific campaigns with intense scrutiny. They understood that their pre-war assumptions, that the sea was a barrier, that heavy weapons would arrive only after the initial landings, had failed catastrophically. The reconstituted self-defense forces built their doctrines on the opposite premise, that modern war demanded mobility, integration, and the ability to project power seamlessly across environments. Even nations that had not been directly involved in the Pacific War absorbed the lesson. Amphibious capability became a defining feature of modern military power, with navies and armies worldwide developing vehicles that could transition from sea to land without pause. The Sherman's influence was not confined to doctrine. It reshaped the design philosophy of armored vehicles themselves. Engineers now understood that tanks did not have to be tied to roads, ports, or prepared terrain. They could be designed for versatility, for multi-domain operations that combined naval, land, and even air elements into a single coordinated strike. The concept of the beachhead tank evolved into broader ideas of expeditionary warfare, with the notion that armored firepower could appear unexpectedly at any point on a coastline and immediately alter the balance of a battle. Even decades after the last amphibious Sherman rolled into the surf, its legacy could be seen in the specialized vehicles that followed. The Cold War era saw the development of amphibious infantry fighting vehicles, floating armored personnel carriers, and even main battle tanks designed with river crossings and littoral assaults in mind. The principle remained the same. Deny the enemy the luxury of predictability. Do not let them assume where or when your heaviest weapons will arrive. Strike with full force from the very first moment. For historians, the impact of the Amphibious Sherman lies not only in its technical achievements, but in how it changed military thinking. It forced planners to consider that the battlefield was no longer confined to distinct domains, sea, land, and air, but was a continuous environment where operations could flow seamlessly from one to the next. This concept, revolutionary, in the 1940s, would become foundational to modern combined arms doctrine. The lessons of those machines that swam ashore on Saipan, Tinian, and Okinawa continued to ripple outward long after the war ended. They influenced the design of landing ships, the training of armored divisions, and the very way nations thought about projecting power across oceans. For Japan, they were a reminder of how quickly assumptions could be overturned. For the United States, they were proof that innovation could reshape the nature of war itself. And for the world, they were a warning. The sea was no longer a moat. It was a pathway, one that could deliver not just men and supplies, but the full weight of mechanized firepower from the very first minute of battle. In that realization lay the enduring legacy of the Amphibious Sherman, a legacy that would define the shape of modern war for generations to come. In the quiet aftermath of the war, when the smoke had cleared and the imperial banners had been lowered, many of the men who had once defended the islands of the Pacific found themselves confronting an unsettling truth. In interrogations, memoirs, and interviews recorded by Allied intelligence officers, former Japanese soldiers and commanders repeatedly returned to one particular weapon when describing the most demoralizing moments of the conflict. It was not the aircraft carriers that projected American power across oceans, nor the endless fleets of bombers that turned cities into ash. It was the sight of tanks crawling out of the sea, machines that defied their understanding of warfare and laid bare a weakness deeper than any tactical miscalculation. For these veterans, the Amphibious Shermans represented something far greater than mechanical power. They symbolized an enemy whose strength lay not just in weapons, but in a capacity to adapt and reinvent the very nature of war. Time and again, captured officers remarked that the tanks themselves were not invincible. They could be damaged, disabled, or even destroyed. What made them so profoundly unsettling was what they represented. A system that identified a problem, the vulnerability of infantry in amphibious landings, and solved it completely. That ability to convert a theoretical idea into a battlefield reality stood in stark contrast to Japan's own war effort, which often struggled to move beyond traditional strategies and rigid doctrines. Many officers admitted that they had underestimated the United States precisely because they had viewed it through the lens of their own strategic thinking. Japan's military culture placed enormous value on courage, endurance, and sacrifice, qualities that had sustained the empire through decades of conflict. Material shortcomings, they believed, could be overcome by willpower, but the amphibious tanks demonstrated that willpower alone was not enough. America's strength lay in a different domain, its capacity to harness science, engineering, and industrial might to solve practical problems and then scale those solutions across an entire theater of war. They did not see obstacles as permanent. One former colonel wrote in a post-war memoir, they saw them as puzzles to be solved, and once solved, they never faced the same obstacle twice. The shock of this realization went beyond the battlefield. It forced many veterans to question the strategic assumptions that had guided Japan throughout the war. The empire had invested heavily in static defenses, trusting that geography and discipline would compensate for material disadvantages. Yet, those defenses, painstakingly constructed and manned with unwavering resolve, had been bypassed or obliterated by an enemy that refused to accept traditional limitations. Amphibious Shermans were not just tanks. They were proof that America could make the impossible routine, that it could approach war as an engineering challenge and solve it with relentless efficiency. In letters and memoirs, some Japanese veterans described the tanks in almost mythical terms. They were monsters born from the sea, iron creatures without hesitation, machines that changed the shape of battle. But others were more philosophical. They saw in the Shermans a lesson about national power itself. Industrial strength, scientific innovation, and logistical sophistication were not secondary to bravery. They were the foundation upon which victory was built. Japan had underestimated that truth, and in doing so, it had waged a war it was never equipped to win. This reflection would have far-reaching consequences in the years that followed. As Japan rebuilt itself in the post-war era, its leaders and military thinkers drew heavily on the lessons learned from defeat. The emphasis shifted from glorifying sacrifice to mastering technology, from relying on static defenses to prioritizing flexibility and rapid adaptation. The very qualities that the amphibious Shermans had embodied, ingenuity, integration, and scale, became guiding principles of Japan's post-war transformation into a technological powerhouse. For the soldiers who had faced them on the beaches of the Pacific, however, the memory remained deeply personal. They remembered the sound of treads grinding against coral, the spray of water cascading from armored hulls, the disbelieving silence that fell over their ranks as tanks appeared where none were supposed to be. It was in those moments, many later, admitted that they knew the war was unwinnable, not because their courage had faltered, but because they had glimpsed the full scope of what they were up against. The amphibious Shermans were not just weapons of war. They were proof of a civilization's ability to think beyond the present, to reshape reality itself. And that, more than any bomb or bullet, was what broke the spirit of Japan's defenders. By the final months of the Pacific War, the once unthinkable spectacle of tanks rising from the sea had become a familiar feature of Allied assaults. The astonishment that had gripped Japanese defenders at Saipan and Tinian had faded into grim recognition by Okinawa. Wherever the United States landed, armored steel would follow immediately behind the first waves of infantry, sometimes even leading them. The transformation was so complete that by 1945, the presence of amphibious Shermans was no longer a tactical surprise, but a strategic expectation. They were part of the landscape of war now, as integral to amphibious operations as landing craft or naval gunfire. The change they represented went deeper than the immediate battlefield, reshaping how nations thought about power, technology, and the conduct of war itself. The M4A3 Sherman Amphibians had proven that warfare in the industrial age was not bound by old assumptions. Before their debut, amphibious doctrine had been shaped by the logic of 19th-century military engineering. Ships delivered men and supplies, who then fought their way inland to make room for heavier weapons and vehicles. The sea was a barrier, and armies planned their campaigns around its limitations. But the amphibious tank erased that barrier. It turned the shoreline from a dividing line into a point of convergence, a place where naval, ground, and industrial power met. It demonstrated that the greatest weapon in modern war was not a single machine or weapon system, but the ability to fuse technology, logistics, and tactics into one seamless whole. This lesson left a lasting mark on military thought. After 1945, no serious power would plan amphibious operations without accounting for the possibility of armored support in the opening phase. New generations of amphibious vehicles, from floating armored personnel carriers to specialized assault tanks, were developed by nations determined not to be caught unprepared again. Naval architecture changed too, with ships designed specifically to deploy tanks directly into the surf. Even armies far from the Pacific took note, integrating mechanized support into their amphibious doctrines and studying how logistics and engineering could collapse the boundary between sea and land. For Japan, the lesson was even more profound. The empire had entered the war, believing that its soldiers' discipline, its island fortifications, and its naval prowess could compensate for any industrial gap. The amphibious Shermans shattered that illusion. They showed that courage and cunning, while vital, could not substitute for an economy capable of solving problems at scale. They exposed the fatal flaw in a strategy that relied on static defenses against a dynamic enemy. And in doing so, they laid bare the truth that would shape Japan's post-war future. Survival and strength in the modern age would depend on technological innovation and industrial adaptability, not on the heroic endurance of the individual soldier. The legacy of the amphibious tank extended beyond military doctrine and national strategy. It shaped the way societies understood what was possible. The Sherman's journey, from blueprint to battlefield, from factory floor to coral reef, was a story of industrial democracy at work. It was proof that vast logistical networks, innovative engineering, and coordinated production could transform even the most improbable concept into reality. This realization did not end with the war. It influenced how nations approached reconstruction, how they invested in science and technology, and how they envisioned the projection of power in a world where oceans were no longer obstacles, but avenues. By the time the guns fell silent in 1945, the amphibious Sherman had done far more than break beach defenses. It had rewritten the language of war itself. It showed that the future belonged to those who could blend creativity with capacity, who could turn theory into thousands of functioning machines and deliver them to any shore on Earth. Its tracks left more than scars in the sand. They carved a path into the future of warfare, one where industrial power would define not only how wars were fought, but whether they could be won at all. And though the Shermans themselves would eventually be replaced by newer, more advanced machines, their legacy endured, echoing in every modern amphibious vehicle, every expeditionary landing, and every strategic calculation that treats the sea, not as a moat, but as a launch pad. In the end, they were more than tanks. They were the embodiment of a new era, one in which imagination, production, and power converged on the tide.